One. Hello, welcome to another edition of Data in the Hallway. On this episode, we're very excited to have Jan Kooi joining us from Amsterdam. We at PingCAP, we released our serverless solution in 1GA about July timeframe last year, and we've been looking to host someone on our podcast that are thought leaders in the serverless space. So it's great to have you, Jan. I mean, you're an AWS hero, and you have your own podcast called The Real World Serverless, and I got a chance to listen to a couple of episodes, and obviously you have a lot of experience in AWS, but one of your recent guests, I think you talked about Azure serverless a lot, and then another episode that caught my attention. I'm a big soccer or football fan, and there was an episode you talked about DAZN. I guess you worked there as well. So it was interesting to hear about some of the technical challenges that you folks had to tackle at DAZN, which is for those of you who don't know, there's a great platform on where you get to watch different sports beyond soccer on internet streaming platforms, but. Let me just stop there, but Jan, I'll let you introduce yourself and we'll get started.
Yeah, sure. My name is Yan, and I've been doing stuff on AWS since about 2010. I went through the whole journey of running EC2 to running containers to wondering why am I doing the same thing every time. Every time I start a new project, is the resource planning and running servers, setting up machine images, all this same stuff that I got to do before I get to writing that first line of code that I actually need for my application. And so when Lambda first was announced in 2014, it was kind of like there's not much you can do with it. You can trigger a Lambda function when you upload a file in S3, but I think 2015, that's when they introduced the API gateway integration. And from then on, that's really when it really piqued my interest in the, building stuff using Lambda and not having to run any servers and manage anything myself. And since then, that's been my focus. I guess I turned full-time independent consulting, I guess around the 2019. Last couple of years, I've been working for myself. Most of my time, I work with clients, helping them adopt serverless. I do a lot of the, the educational side of things as well. I teach people on my courses on the internet, social media. I also work with Lumigo, which I still consider as the best observability platform for people that are building serverless applications. They support containers, EKS, and all of that as well. But I still don't run much containers myself. So I mostly just know them for the serverless application side of things. And I work with them a lot on the content side of things because I'm a big fan of their platform. And so sometimes I represent them as a developer advocate at conferences, even though I'm probably not a very good dev rel for them because it's not something that I do full time. But yeah, I do a lot of things on the internet. I guess I don't. That's kind of just my focus right now is just trying to help the community with serverless and try to get more people interested in this paradigm.
Cool. Yeah, I mean, there are a lot of breadcrumbs if you search for Jan's name on Google or even just YouTube. There are a lot of, I mean, I think you're being very modest, Jan. Like your presentations and your discussions are, I mean, anybody would be excited to have you as a DevRel advocate, I think.
Thank you.
So yeah, I mean, just starting with something pretty basic. I mean, you mentioned like Lambda. I mean, it's like 10 years ago when it was first introduced, so it has a bit of a history. Almost 10 years. Like, for novice people, like even people like me, like how would you define serverless, and what are some of the key characteristics of serverless versus other like a cloud deployments?
Yeah, I mean, I guess when we talk about serverless, a lot of people think about Lambda and the functions of service, and Lambda probably is the poster boy for serverless. But I think at least my definition of serverless is broader than that, and I think you speak to a lot of people who's been doing serverless for a while. They'll have a similar definition to me. In that we kind of describe anything as serverless that meets a number of criteria. So number one being that you just don't have to worry about the machine image provisioning and managing the underlying servers is one. The other one is that you should be able to scale to zero. That's a big thing, and it's quite important one because it supports some of the most important practices that has evolved with serverless, namely the use of temporary or ephemeral environments, whereby I can create a new entire environment for my application, when to start doing some work. And the reason why I can do that is because I'm only paying, that's the third point, which is ideally you only pay for usage and there's no minimum cost. So that way, when I start a new feature, I can create a new branch, I can set up a new environment, I can work against that environment without touching anyone else's code and affecting anybody else. And when I'm done, I can just tear down the environment. So any moment in time, I can have many concurrent environments. But because we only pay for usage, so there's no cost overhead for having 10 different environments of the same application running, and you don't have to have people talking about, okay, who gets to run the deployment on on dev, so you can run some tests to see if that code change is working. So you can have as many sort of temporary dev environment for your application as you need. And that's a really powerful practice when it comes to building applications and scaling the teams so that the different people can take on different pieces of work at the same time. So in terms of I guess the key requirements or definitions for characteristics of a serverless, that's kind of my sort of top three. They need to basically allow you to not have to manage any machines and servers. It scales to zero. And so when there's nobody using it, essentially you're not going to pay for anything. But also importantly, it should have a usage-based pricing with no minimums. And unfortunately, AWS themselves has been guilty of releasing services or labeling services as serverless, where they don't have scale to zero, they don't have a usage-based pricing. If you look at something like OpenSearch serverless, that's probably one of the more egregious, I guess, offenders, because you pay, I think a minimum charge you pay is about $700 per month, even if there's no usage, because there's no scaling to zero, and it's based charge based on uptime instead of usage. But it's labeled as serverless, which is not not by my definition. But you see quite a few examples of that in the last couple of years from AWS, which is unfortunate.
Yeah, and I think you mentioned like in the early days of Lambda, like once what really piqued your interest was like availability of, like, I think it was API gateway like a year after the Lambda launch. I mean, what are some of the important, like, if you want to talk about evolution over the last 10 years, what are some of the other important developments for serverless?
I think the API gateway one was a really big one because it
Mm,
allows you to build more than just toys. I mean,
mm,
imagine the only time when you can run your function is if you invoke the function directly yourself or by dropping a file into S3. So there's a very minimum amount of things you can actually build. But once you have that API gateway integration, that means that you can now build REST APIs, and most people
mm,
building REST APIs for their systems in some shape or form. And so that really opens up to more sort of broader adoption of Lambda as a general purpose compute platform for your application. After that, you have more and more integration to different services. And I think Event Bridge is a really big one because that again formalizes building of event-driven architectures. Before you have SNS, you have Kinesis, you have CloudWatch events before the rebranding. But there's also, I guess, consensus around what is the best choice when it comes to using it as the centralized event bus to sort of facilitate that end-to-end communication pattern you find in more complex systems where you got lots of different independent services publishing events about state changes, and then other services react to them, and you need other things around that in terms of archiving, replaying events, as well as some kind of a schema registry. So all of those things happened, and so that really kind of beefed up the kind of things you could do with Lambda, not just in terms of what Lambda itself can do, but all the different things you can then integrate into the whole ecosystem. And I think that's one of the biggest strengths that the AWS has on the serverless side of things, is that the overall ecosystem is much more connected and much more complete compared
mm,
to, say, GCP or what you have on Azure Functions. Other things in terms of opening up different use cases, I mean, early days, maybe, I mean, not even early days, maybe like 4 or 5 years ago, there was a lot of limitations. That means that people couldn't run certain workloads on Lambda because of the fact that they've got, for example, machine learning is a big one, whereby the 250 meg zip file package size is a hard limit. And it means that if you got any sort of machine learning workload you want to run, well, chances are your model is going to be 4 times the size of that. And so the support for container images as a way to package your function means that you can now package up to 10 gig of content into your artifact, and you can still run it as a Lambda function. There's small overhead, but it opens up, again, removes those roadblocks. There's questions about, okay, cold starts is still a problem for some workloads, which over time they have done a lot of improvements to improve cold starts, both in terms of the frequency, how often you see it, but also in terms of the performance. So when it does happen, how long does it actually take to cold start? So they've done a lot of improvements on the underlying platform to improve those factors. But sometimes you still just want to say, we have a fairly stable traffic. We just don't want to see any cold starts at all. And so that's where things like provision concurrency is also, again, removing some of those roadblocks. And then you look at communities like Java and the .NET, where, okay, because of the way the runtime works, it just doesn't work very nicely with the function as a service paradigm, where you need to cold start on demand when a request comes in. So things like snap start, things like ahead of time compilation, all of those things has now opened up the Lambda as a viable compute platform for many workloads that just wouldn't have fit the paradigm a few years ago. So over time, they've added lots of I guess quality of life improvements that allowed more and more workloads to be able to use Lambda as a viable platform. And the scaling change they've done recently, I said recently at the re:Invent 2023, also means that my previous job at the Zone, one of the things I talked about recently on LinkedIn is that back when I was at the Zone, we have, for people that follow, I guess, the live sports, how everyone comes in to watch some big football match about 30 seconds before the match starts. Nobody logs in like 10 minutes and just wait and just it's going to start, right? So we have crazy spikes in traffic. When you consider that we have many millions of concurrent users at peak, it means that everybody logs in around about 30 seconds before the match starts. So you have this massive crazy spike in traffic. And so because of that, Lambda had this sort of region-wide concurrency limit. So it means that for any of our APIs along that critical path of somebody logging in and and then selecting a match to start watching, any of those APIs couldn't run on Lambda because of how spiky our traffic is. And the magnitude of that spike, it goes from a few hundred requests per second to many tens of thousands of requests per second. So that kind of throughput means that, okay, we will run into a really hard limit on Lambda in terms of how scalable it is. It is infinitely scalable potentially, but you have to wait a long time to get that peak concurrency. So at the re:Invent 2023, they make a big change on that how scaling works. So now individual function can get up to 1,000 concurrency units per 10 seconds on individual function level, which means that you can, as a whole account or region, you can go up by maybe tens of thousands of concurrent executions per 10 seconds. And that can translate to many, even more. Imagine one instance of a function can handle a single request in, say, 100 milliseconds. That means that one guy can handle 10 requests per second, multiplied by the number of concurrent executions you can have per 10 seconds. Then you can get this really high throughput increase in a very short space of time. So even with the kind of crazy workload that the Zone had, probably still have. I mean, nowadays, Lambda might also be a viable platform because those traffic doesn't happen constantly. It's just when the match about to start, a very big match, that happens once every couple of months or whatever, you get this crazy spike. But a lot of the time, you have really smaller spikes, which are, obviously fine. So I guess over the last couple of years, there's just been a lot of improvements in terms of both the Lambda platform itself, but also the overall ecosystem. And so nowadays, you can pretty much build anything you want, including WebSockets, without having to run any servers. I've been working with lots of different clients, and the last couple of years, I've not had to, well, very rarely do I have to actually bring in a container. And when I do that, Fargate kind of gives me an easy way to run containers without having to think too much about the underlying infrastructure.
Right. Yeah. I mean, obviously, it's like with every other technology or platforms. It's like with new use cases and emerging technologies. I mean, you mentioned like LLMs and a couple of other things. Like it obviously had to evolve to remain popular and as a platform of choice for a lot of developers. I mean, I think you mentioned one example like earlier. I want to talk about maybe misconceptions about serverless, whether it's positive or negative. I mean, you mentioned, I mean, some people learn the hard way. You can still get surprise bills from your cloud providers, like with serverless. Like particularly in the early days, if you forget to set up the alarms and so forth. I mean, that's one of the things that you know because like one of the value propositions, I'm being very broad here, like you don't have to think too much about infrastructure, but I mean in some ways you still do because you need to pay for the infrastructure at some point. So what are some of the misconceptions that people have about serverless that we need to be mindful about?
In terms of, I guess maybe I can answer that question you have about the cost. Yeah, you can actually guess the cost of prices if you don't understand the tools that you're using. I mean, the fact that it's easier, I mean, it doesn't mean that you shouldn't understand how it works and especially how
Right.
you're being built. And I would argue that with the pay-per-use pricing model is much easier than before to estimate the unit cost of your system in terms of, okay, how much does it cost me to handle one user order? Because you can look at the number of API calls, number of API gateway requests, number of Lambda function invocations, the number of calls to DB, and how long does it normally take to handle one request on a Lambda function. So I can use that to have a pretty accurate estimate for exactly how much it costs me to handle that one user request. And and you can use that to then work out, okay, if I'm building a system and I'm estimating there's going to be so many number of users per day, and then they're going to do a certain amount of activities, and I can translate that to number of API requests and Lambda invocations, and I can have a pretty good estimate for how much my system is going to cost. And of course, if you just start using something without really understanding how it's actually going to be charged, then of course you can be surprised. And lots of people have been surprised because they just, oh, this thing is easy. Let's just throw it
Mm,
out there and run in the wild. That's never a good idea. Doesn't matter
mm,
whether or not you're using Lambda or containers. And at the same time, there's also when I was at the zone, those APIs that we were running on containers. No one talks about the fact that, yeah, sure, if we're running on Lambda, it can be quite expensive when we have those big spikes of traffic. No one talks about the fact that we had over 100, I forgot what is it, 2x, 4x large EC2 instances running ECS and in the lower environment, because every single service needs to have at least one instance of it running in every single environment so the team can do development and run tests and whatnot, multiplied by the number of services you have, and the fact that we run three regions because we need to be really highly available
mm.
for live events because, well, if you miss a goal, that's it. You're not going to get it back.
Right.
So we need
Right.
to be up there, right? During the
Right.
event, we have to be up to 100% of the time, pretty much. And so we run the multiple instances, multiple regions in the lower environments as well. So that all amounts to a large number of idle EC2 instances that we are paying for. And that's the same with a lot of companies I've seen where they look at a lot of that and say, oh yeah, it's fine, we're paying for those. We are using them because we have allocated space on those containers. Even never mind the fact that your container is running a 5% CPU, so is your overall cluster. So we seem to think about waste differently when it comes to things that we are paying for uptime versus things that we're paying by usage. But absolutely, you can still make mistakes with Lambda, especially when you have a high throughput API that you haven't sort of done the homework. You just slap API gateway and Lambda, and suddenly you find that it's a lot more expensive because your API is running consistently, thousands of requests per second.
Mm.
So you can absolutely make those mistakes. I wouldn't say that's a misconception. That's just, I guess, a mistake that people can make when it comes to the cloud, when it comes to using new services. And I've seen the same thing play out with other services as well, things like S3 Macy, very powerful service that does machine learning stuff, look at your data and see if you've got PII and other things like that. But if you don't look at the pricing and start using it, you may find that oh, wait a minute, that's actually quite pricey for when you have a large amount of assets in S3. So every I guess take it as a rule of thumb that before you use the AWS service, always look at the pricing page. There's always details there.
Mm-hmm.
It's not always obvious exactly how it's going to play out, but it's worth understanding understanding the pricing model, and maybe use the AWS cost calculator to work out, okay, given some estimates you have about your system, how it's going to work, what that translates to in terms of estimated cost. But that's a lot easier when you have that pay-per-use pricing compared to when you're just paying for uptime for some EC2 instance. You have no way to figure out, okay, how many requests are you going to handle and on that particular instance and so on. In terms of misconceptions, one thing that still comes up a lot when I talk to people who are, I guess, not familiar with serverless, or they have read about it but haven't actually done any serverless, is that they think of serverless architecture as just a bunch of Lambda functions hanging there by itself and just pinging each other, just have this ball of death where messages flies around, no one knows exactly what's going on. But that's not how people actually build systems, and that's not. That's if you're actually paying attention to what you're doing and you're building, you're following microservices architectures and the best practice around that, and that's not how you're building systems. You're building systems exactly the same way that you would do with containers and building microservices. You have your service boundaries, and between different services, you're going to be communicating maybe through shared events to maybe some event bus. So you're doing a choreography between different services, and within the boundary context of a given service, if you got some multiple steps you need to do to implement some kind of a business workflow, like taking orders or taking payments, you probably use something like step functions to orchestrate that workflow. So yes, you may have multiple Lambda functions involved in a given user transaction, but it's not going to be just those Lambda functions hanging by itself. When you got APIs talking to each other, you're not going to be exposing a Lambda function as the API to your service, because that is an implementation detail. You want to expose an API to your caller so that they're gonna call your API. You have your API contract. Today you may decide to use Lambda. Tomorrow you may realize that, oh yeah, our throughput is really high, it's really stable now. Let's move them to containers. That shouldn't be impacting your callers. And so you wouldn't just have a Lambda function hanging there as the interface to your system. And then the misconception that comes up a lot is that, Lambda, you can't do any local development. There's no local development experience. Again, that's just not true at all. There are different ways you can do local development experience. You can, in terms of be able to change your code, test them locally before you have to deploy to AWS and wait like a minute or 2 minutes for that deployment cycle before you can validate your code and make sure it's working. There's the coding patterns like hexagonal architectures where you can create abstraction layers so that they allow you to test different parts of your code against the local mocks when you're running them locally. But then in the real execution environment, they'll be talking to, say, the real DB tables and whatnot. So you can apply coding level, patterns like hexagonal architectures. You can do what I often do, what I call remote testing, by combining elements of local and local testing. So running your function code locally against remote services. And so in that case, your Lambda function is just a function. So ultimately, you can call that function. If your function is calling out to DB to read some data, well, have it talk to the real thing. And that works really well when you have ephemeral environments, because before I start a feature, I can create a new temporary environment with my DB tables and whatnot. So as I add a new feature that's going to read from a table, I can write the function code, I can write tests for it, execute the function code, put breakpoints in my IDE to see, okay, there's a problem here. I don't really understand what's going on. So put a breakpoint, see my code steps through it line by line, look at the state or in my local development environment. And only after I'm happy with the code, then I deploy the whole thing and then run end-to-end tests to check the whole thing is working by calling, say, the API endpoint directly from the outside. You have local simulators like local stack. You have got things like, frameworks or just tools that allows you to run the entire, say, Express.js application inside a Lambda function, what we call a Lambda lift. There's things like the AWS web adapter that makes it easy to convert the Lambda's invocation kind of payload to say Express.js or whatnot. So if you're just running Express.js in Lambda, then you can apply the same testing methodology to how you're doing things right now if you were to run Express.js in a container. So there's different ways you can get the really good local dev environments to still have that fast feedback loop, so that when you're making code changes, you can test them locally and quickly. And lastly, I guess another one that I see a lot is that people think Lambda is only good for I/O work. You can't do CPU intensive work, despite the fact that Lambda functions gives you virtual CPU cores, and a CPU core is a CPU core. Doesn't matter if it's running, your code is running on container or on EC2, or Lambda function is running on some machine somewhere, and you're getting CPU cycles. And so with Lambda, you allocate 1.8 gig of Lambda of memory, then you get one CPU core. You allocate more, you get more CPU cores. So with a 10 gig of memory, you can actually allocate 6 CPU cores. So combine that with how fast Lambda scales, you can actually use it as a supercomputer. And there's some organizations that use Lambda for high performance computing work because you can get so much CPU so quickly. Sorry, that's
Great.
kind of a bit of a
No,
long.
that's all right. Thanks. Thanks for not only providing like detailed answers, but you preempted my next questions about like considerations for developers too. So this is perfect. Somewhat related to like considerations for developers. Like I'm sure you've had conversations about this with some of your clients. Like if someone wants to migrate some of their solutions to serverless, like what are some of the considerations that what are some of the key considerations that as they think about migrating some of their solutions? Are there good solutions to start with, or what are some of the general approaches that you normally recommend?
Yeah, because the first thing would be to consider whether or not the Lambda is even a good fit for your use case, but also not just for your use case, but also for your team, because your team may not be familiar with AWS, and suddenly you're asking them to change the way they build software, but also if you also want to change to say DynamoDB, so you're changing database paradigm, and if you're going from monolith to more of a microservices architecture, then again that's another paradigm shift you're taking on. So oftentimes I try to tell clients to limit the number of things that are changing all at once to maybe one or two. As opposed to changing the whole shebang, the house and the garage and the cat. And so you want to limit the number of things you have to sort of tackle at the same time, because it's difficult. It's not something that you can do easily. People like myself, we've gone through this over the course of 10 years as opposed to over the course of 10 days. Another thing to consider is that maybe you have a more like idiomatic way of doing certain things with serverless, maybe, and you want to get to a certain point where you want to everything's going serverless, from database to your compute to your API management. But maybe start by just limiting some of those ambitions, and for example, instead of having API gateway and the Lambda functions, and you have single purpose Lambda functions that handles one endpoint at a time, maybe you just take your Express.js, take your application as it is now, run it as a Lambda lift inside Lambda functions, so you get some of the benefits from the compute platform in terms of being able to scale very quickly. But no, you're not going the full fine-grained single-purpose functions, which are many still considered as myself included, still considered as the best practice. But maybe that can be step two. Step one would be just try to move your compute platform to get people familiar with working with Lambda, working with API gateway, and getting used to delegating responsibilities like authentication to API gateway and Cognito, as opposed to doing it in your own code through middlewares and things like that. And then maybe you can look at, okay, can we change our database from relational database where we are paying for uptime for this big RDS cluster to using DynamoDB, because most of what we're doing is just simple CRUD, looking up by key. So we're not really taking full advantage of the relational database model. So looking at those things as different problems that you tackle one at a time as opposed to all at once, that's probably the biggest thing that
Hmm.
I would advocate for when it comes to migrating to serverless is don't try to take on all the problems, all the challenges all at once.
Yeah, that's great advice. So, a couple more questions for people that are, starting their journey in serverless. I mean, what are some of the favorite resources that you point them to? Like it could be a blog post or books that maybe somebody published, or whether it's GCP, like a Google Functions or AWS Lambda. If you go to their pages, there are plenty of resources available. But I wanted to see if there are uh, few things that you recommend for people that they can read up on, and I'll be happy to include them in the podcast description as well. But
Yeah, so I don't really know much about Azure Functions or
mm,
GCP, so
mm,
it's not something that I've spent much time with.
mm,
So I can really talk about what would I point someone to when it comes to learning AWS and
mm,
serverless stuff over there. One of the things I'll say is go check out my blog, theburningmonk.com. I've got a lot
mm,
of hundreds of articles I've written on various different things. I've got a newsletter as well, so that you can get all of my content straight to your inbox. Um, and I've got a YouTube channel as well. You can also find it on my blog. There's also a podcast. I think you mentioned that already. There's also a very good newsletter, Off by None, by Jeremy Daly, who was also one of the, I guess, very first, very early adopters of serverless. In terms of books, there's a book by Joe Emerson. I forgot the name of the book. I think it's Serverless, a Game Changer. Yeah, Serverless is a Game Changer. So Joe Emerson, who's the CTO and co-founder of Branch Insurance, he's
mm,
also someone who's very experienced with serverless, and he's very familiar with from the business side of things in terms of
right,
building a business using serverless technologies. As a differentiator. And so his book is really good to giving you the high level view of why should the businesses care about the serverless, but also why should the developers care about serverless
right,
as well. Other than that, you have quite a few other newsletters that are focused around serverless. There's the Ready Set Cloud, which newsletter, blog and newsletter and podcast by Alan Helton as well. There's
okay,
also the blog by Lee James Gilmore, who's often writing about the serverless adoption from the some more enterprise angle. So you've got a few people that are sort of looking at serverless more from the sort
right,
of enterprise side of things, which I think is very interesting because oftentimes some the problems that you kind of talk about as a startup is going to be very, very different from
mm,
the kind of problems that this enterprises care about. And in fact, that's to the earlier question about some of the big moments in serverless in Lambda
mm,
development, removing the co-star penalties for VPC. That was a really big one for
mm,
enterprises because VPCs is practically a mandatory requirement in the enterprise environment. But yeah, so there's quite a lot, there's
yeah,
quite a lot of blogs and the podcasts and whatnot that focus on serverless development and some of the best practices. And I've also got a workshop that I run every couple of months called the Production Ready Serverless, where it's more of an end-to-end thing where I kind of take you all the way through. So instead of you reading different blog posts and trying to get putting together an idea of how to do things yourself. It's more just okay, this is how you start, how you develop, how you test, how you do observability, how to do event-driven architectures, all in one, just kind of like a boot camp thing that takes you always through. But yeah, happy to also just send you a list of other things that I am not able to come up with off the top of my
yeah.
head
No,
right
no,
now.
this
But I've got
this
a
is
list of
great.
things I often share with
Yeah.
other people.
Yeah, no, I mean the challenge nowadays, not just with serverless, but anything else, if you want to start research, it's just so overwhelming. Like you don't
Oh yeah,
know
yeah.
where to start. So just yeah, just starting with like a few of the things that you recommended, I mean, I think it's definitely going to be helpful for our listeners. So we come to the end of the podcast, and we have a tradition to ask all our guests to tell us about where they live. And you live in a wonderful city of Amsterdam that I've been fortunate enough to visit twice in my life, and I thoroughly enjoyed both occasions when I was I mean, walking around and touring the city and enjoying the culture. But tell me something about Amsterdam that most people may not find out about from tour guides. So
Yeah, sure.
yeah,
I mean, people always, everyone knows about Amsterdam and well, Netherlands and the bicycles. Everyone cycles,
right,
everyone, well, everywhere. And there's a fun fact is that there's actually more bicycles in Amsterdam than there are people. I think something like
right,
this ratio of like 2 to 1 or something like that.
right,
Maybe because a lot of people come here, live here, they get a bike, and then when they leave, well, they just leave the bike behind. So there's actually more bikes
right.
in Amsterdam than there are people.
Wow, yeah. I mean, it's a wonderful city to bike in. The infrastructure is definitely there. And
Oh
then, I
yeah.
mean, nowadays, like in most modern cities, even in North America, you see a lot of bike rental places where you can rent bikes. And but when I was first went to Amsterdam almost 20 years ago, that was kind of unusual for an American to you can just go up to like a corner shop and rent a bike for like a half a day to tour the city. And yeah, I did see a lot of abandoned bikes in different places in Amsterdam,
Yeah.
so that was pretty unusual. But
Yeah, it's not just about the easily,
yeah,
being able to rent a bike easily, but it's
yeah,
more about the safety on the road. You always
right,
there's always a physical barrier between you and the car lanes,
right,
and a lot of dedicated streets that are only bicycle and
right,
pedestrians. There's no the cars are not allowed. So
right.
most of the time to get from point A to point B, the fastest and the cheapest way is to go by bike because the car have to go all the way around.
Right, right. Yeah, I mean, it's kind of interesting. Like one of my former colleagues at my previous job on a Slack channel asked for recommendations on things to do in Amsterdam, and a lot of people like recommending, go to this museum, go to this market. And one of the things I said was make sure you rent a bike for half a day. That's a great way to see the city and the surrounding environment. So. Well, I
Yeah,
mean, thanks
absolutely.
again, Jan. It was nice to meet you, and wonderful to hear your thoughts on serverless and the evolution over the past decade or so. And uh, stay safe, and we'll talk. Hopefully, you'll get a chance to meet you in person in Amsterdam on a bike. All right,
Thanks for having me around.
all right,
And
all right.
yes, hope we'll see you some other time. Take it easy,
Yeah.
guys. Okay, bye bye.
Thanks.